Very good evening to all of you and welcome to the class. So this is the weekend class and we all know that in this class we are basically going to solve numericals, right? So in today's class, basically we are going to solve numerical related to the gaseous state, right? So this is going to be a very interesting chapter, and this is going to be a very interesting class for all of you, right? In this chapter, we are going to solve some numericals, or we say some previous year questions from the gaseous state chapter, that is states of matter, right? So the topic is clear for today, what we are going to do today, right? Now, so I'm Vivek Tiwari and I hope my screen is visible to all of you. Hmm? Okay, right. चलो शुरू करते हैं हम लोग आज का अपना जो मेन है कि क्या करना है हम लोगों को. So basically we are going to solve numerical related to the problem solving on the gaseous state class 11. ठीक है. So this is the first question as we see in your screen. I hope सबने ये चैप्टर ऑलरेडी कर लिया होगा, स्टेट्स ऑफ मैटर गैसियस स्टेट. ठीक है, ये चैप्टर ऑलरेडी तुम लोगों ने कर लिया है. गुड आफ्टरनून बेटा, गुड आफ्टरनून. ठीक है. सो ये क्वेश्चन हम लोगों को करना है अच्छे से. ठीक है. So the correct van der Waals equation for the 1 mole of real gas is. So we all know that what is ideal gas, huh? GNP Bhavnagar Gujarat. Yes, beta. Very good evening. So we all know that. क्या पता है हम लोगों को? We all know that ideal gas equation is what? So ideal gas equation is equal to PV is equal to nRT, right? So this is the definition of the ideal gas equation. For the 1 mole of gas, if n is equal to 1, then this PV is equal to RT. ठीक है. This PV is equal to RT. ये PV किसके इक्वल हो गया? RT के इक्वल हो जाएगा, right? This PV is equal to RT. Now, the correct van der Waals, इसको रियल गैस इक्वेशन भी बोलते हैं, van der Waals गैस इक्वेशन को. So in the van der Waals equation or the real gas equation, there is a correction in the pressure as well as the correction in the volume. ठीक है. तो प्रेशर और वॉल्यूम दोनों में ही क्या आया? करेक्शन आया. So there is a correction in pressure as well as the correction in the volume. So which one is the correct real gas equation? That is correction factor in pressure, that is A upon V square. A upon V square. So this is the correction factor in the pressure. And what is the correction factor in volume? That is V minus P. And this is equal to RT, right? This is equal to RT. So this is the van der Waals gas equation, or we say the real gas equation. So out of these, which option is correct, beta? That is A. That is P plus A upon V square, V minus V is equal to RT. Where P is the pressure, A and B are the van der Waals constant, and V is the volume, right? And R and T, R is the universal gas constant and T is the temperature. So this is a very simple question, और ये नीट 2023 एग्जामिनेशन में आया भी था. The correct van der Waals equation for the 1 mole of ideal gas. ठीक है. So I hope this is clear to everyone. सबको clear हो गया होगा कि क्या है एक मोल गैस के लिए van der Waals equation. ठीक है. चलो. Now, ये क्वेश्चन भी आया था 2023 में. That is the correct option in which the density of the argon is the highest. So you have to find the correct option in which the density of the argon is highest. So we all know that there is a small relationship between density and pressure. You all know this thing, or I need to establish the relationship between the density and the pressure. चलो मैं एक बार कर देता हूँ. We all know that beta PV is equal to nRT, right? We all know that PV is equal to nRT. Now this is P and this is N. N means what beta? N is molar, mole. N means that is mass upon molar mass. We can write mole as mass upon molar mass. And this is R, this is T, and divided by V. We all know that this is mass upon volume. So what is this mass upon volume? So mass upon volume is density. So this is equal to D R T divided by capital molar mass. Okay. So this is the relationship, right? So this is the relationship between, that is density is equal to Pm upon RT, right? Density is equal to Pm upon RT. So this is the relationship between density and the pressure. Okay. So this is the relationship between density and pressure. So we can say that कि pressure should be maximum and temperature should be minimum. ठीक है. For the maximum density, अगर मैं बोलूँ कि density maximum हो, if the density is maximum, then क्या होना चाहिए? Pressure क्या होना चाहिए? Pressure must be maximum. क्योंकि प्रेशर तो ज्यादा हो बिकॉज प्रेशर डायरेक्टली प्रोपोर्शनल है, एंड टेम्परेचर मिनिमम होना चाहिए बिकॉज टेम्परेचर क्या है बेटा, इनवर्सली प्रोपोर्शनल है, राइट. सो फॉर द मैक्सिमम डेंसिटी प्रेशर मस्ट बी मैक्सिमम and temperature must be minimum, right? These are two only the criteria, because we know that density is directly proportional to pressure and inversely proportional to temperature as from the relation, right? As from this equation number 1, or we say from this relation. We already know this thing. So how will you came to know? कैसे पता लगेगा तुम लोगों को, ठीक है? So very carefully observe all the four options. You got to know in the option C we have the minimum temperature of 0 degree Celsius and the 4 atm. Here also we have a 0 degree 273 degree Celsius, but here pressure is maximum, that is a 4 atm, right? So this one is absolutely correct, right? That is the 0 degree Celsius and 4 atm. So these are the option in which the density is maximum. So I hope this is clear to you. Clear हो गया सबको? चलो. Now move to the next question. That is 4 gas cylinder containing helium, nitrogen, CO2 and NH3 gases separately, right? Separately are gradually cooled from a temperature of 500 Kelvin. Which gas will liquefy first? And having critical temperature is given. So critical temperature in Kelvin is given. For helium, the value is 5.3. For nitrogen, dinitrogen value is 126. For CO2, the value is 304.1. And for the NH3, the value is 405.5. So you have to identify out of the 4 gases, nitrogen, CO2, NH3 and helium, which will liquefy first, right? So this question is from the liquefaction. So we all know that as from the given data, NH3 has the highest critical temperature, right? So NH3 having the highest critical temperature. So highest critical temperature. So NH3 having the highest critical temperature, ठीक है, which suggests maximum attractive force, and NH3 will be liquefied first. देखो liquefied first का मतलब क्या होता है कि कोई चीज गैस है, right? अब इसको गैस को लिक्विड में कन्वर्ट होना है. This gas want to convert in this liquid, right? So what they did basically, how they convert gas into liquid. So we know that in gaseous the particle is very far away, right? Or in case of liquid the particle is close as compared to the gases, right? So basically, if the attractive forces are more, right? If the attractive forces are more as compared to the repulsive forces, then definitely particle will come together, right? So this is the case. So we know that highest the critical temperature, more the attractive force they have it, right? So highest critical temperature suggests that the maximum attractive force and NH3 will liquefy first. So in NH3 will be liquefied over. It means higher the critical temperature, ease of liquefaction increase होगा. So this is ease of liquefaction. ठीक है. So ये concept आपको ध्यान में रखना है कि जैसे जैसे critical temperature बढ़ेगा, higher the critical temperature we have, ease of liquefaction become very easy. So this is all about. ठीक है. So I hope this is clear. चलो. Now the next question is, that is, which one is not mathematical equation for the Dalton's law of partial pressure, where P is the total pressure of the gaseous mixture, Pi is the partial pressure of the ith gas, and Xi is the mole fraction of the ith gas gaseous mixture, right? And Pi naught is the pressure of the ith gas in the pure state. So बोल रहा है which one is not correct. So you have to identify which one is not correct. ठीक है. So you all know that according to Dalton, the total pressure is the sum of the individual pressure, that is P1, P2 plus P3. So this is the definition of the Dalton's law, right? That is the total pressure is the sum of the P1, P2 and P3. Now this P1, P2, P3 further we can write as, because we know that PB is equal to nRT, right? So we can write this P is equal to nRT upon V, nRT upon V. So we can write as, this is for the first gas, that is N1, and this is N1, and this is RT upon P for the fixed volume, right? R and T are constant, volume is also fixed. Similarly, this will become N2 into RT divided by V. ठीक है. Similar ये हो जाएगा N3, and this is RT by V. So this is the derivation of the basically Dalton's law, right? Now, when you actually did this, what you get to know that is N1 plus N2 plus N3 because all are common RT upon V. So this is the expression for the Dalton's law, right? This is the correct expression for the Dalton's law. So which one of the is not the correct one, right? So you have to identify which of the following is not the correct definition, right? So we can say that this one is the correct definition. Yes, this is also the correct definition, and pi is equal to, this is very important, that is the partial pressure is equal to mole fraction into my total pressure. So this statement is also true, means this is also true. So which is not true, beta? This one, that is option number D. That is pi is equal to xi into pi not. That is the partial pressure is directly proportional to the total pressure. That is partial pressure is equal to mole fraction of the gas multiplied by the total pressure. So option D is incorrect. Rest all options are correct, right? So that's why in this they are asking which is the not the correct mathematical equation. So which one of the following is not the correct mathematical equation, beta? Option number D. So this is not the correct mathematical equation. ठीक है? So I hope this is clear to you. सबको clear हो गया? Tell me first. Everyone got it? Chalo. Now, the next question is, a 10-liter flask contains 64 gram of oxygen at 27 degrees Celsius. Assume O2 gases behave ideally. So you have to assume that this O2 gas is behaving ideally. The pressure inside the flask in bar. So you have to identify the pressure inside the flask in bar. And R is given, that is 0.0831 liter bar. Okay? And a 10-liter flask containing. So this is this thing you also need to remember, right? So let me solve this question. Basically, we have to calculate the pressure inside the flask bar, right? So we know that if the gas is ideal, for the ideal gas, what we know? For the ideal gas, we know that PV is equal to nRT. PV is equal to nRT. What is P? So this P is equal to N upon V RT. ठीक है? So this P is equal to N upon V RT. ठीक है? तो ये P निकल गया. P is equal to N upon V RT. Now we know that P. What is the number of mole? So we can find the number of mole now. Number of mole is nothing but mass of the solid divided by the molecular mass. So here the 64 gram of oxygen is given. So this will be equal to 64 and O2 having molecular mass 32. Okay. What is R and what is T? So RT is, we know that 0.0831. This is the R and temperature is given in Kelvin, that is 300. ठीक है? तो ये टेम्परेचर हो गया हम लोग का 27 डिग्री सेल्सियस है ना, तो 27 plus 273 become 300 Kelvin. Now, what is the volume? So volume is given, I think, 10 liter of flask. So volume is also given, that is a 10 liter. So on solving, just solve this value. This become 2 and this you can solve as 0. So just multiply this 30 into 0.0831 into 2. So you get to the value 4.9 bar. Right? Okay. So 4.9 bar. So which option is correct, beta? 4.9 bar. So actually the option D is absolutely correct. 4.9 bar. So this chapter is very, very easy. If you know some formulas, because this chapter is not very lengthy, we know, right? So if you know some formulas related to the ideal gas equation, their relationship with density, right? And the real gas equation, right? And some liquefaction concept, then you can easily solve a numerical related to this chapter, right? The numerical of this chapter is not so big, right? So you can actually solve numerical by using this formula, right? So just try to learn the formula and look at how I apply फॉर्मूला टू सॉल्व न्यूमेरिकल जस्ट लाइक दिस. अगर तुम लोग इसको अप्लाई करते हो, इसी तरीके से सॉल्व करते हो, सो दिस चैप्टर बिकम वेरी इजी फॉर यू, राइट? चलो देखते हैं अगला क्वेश्चन. सो अगला क्वेश्चन है, बोला है चूज द करेक्ट ऑप्शन, राइट? चूज द करेक्ट ऑप्शन for the total pressure in ATM is mixed when the 4 gram of O2 and 2 gram of S2 confined in the total volume of 1 liter at 0 degree Celsius. Given R is this and T is this. ठीक है? साफ से पता लग रहा है कि this question is from the Dalton's law of partial pressure, right? This question is from the Dalton's law of partial pressure. So what is Dalton's law of partial pressure, beta? That is PT is equal to P1 plus P2. So here we have a 2 gas now. that is O2 and H2. So this total pressure become P1 is equal to PT is equal to P1 plus P2. So we can write P is equal to PV is equal to nRT. So P is equal to N upon V, huh? That is N into RT upon V. So this is RT upon V. This is the for gas number one. Similar, this is for gas number two. That is RT upon V. So take RT upon V as common. So क्या बचा? That is N1 plus N2 into RT upon V. So this is the expression we have. So what is N1 and what is N2 here? So we can calculate this N1 N2. कैसे निकलेगा N1 N2 बताओ? Number of moles. So for oxygen, we know that that is a 4 gram, 4 divided by 32. Similar for 2 gram, right? And this 2 gram divided by 2. Hmm? And this is RT upon V. So RT upon V क्या आ जाएगा जल्दी बोलो. So ये RT upon V आ जाएगा हम लोगों का, that is R. So value of R is already given, that is 0.0821 and the temperature is 273. है ना, 273 Kelvin. What is volume for this question? That is 1 liter, right? The volume is also given 1 liter. Just solve this, right? Just solve. So it's a very simple thing. ये आ गया 1/8 and this is 1 and this is again 0.0821 into 273 divided by 1. So बहुत simple है, उसको just solve करना है and you get the answer like 25.18 atm. ठीक है? So this is the total pressure we have. That is 25.18 atm. So कौन सा हुआ correct? Yeah, option D. So option D is absolutely correct. That is 25.18 atm. ये हो गया हम लोग का correct expression. ठीक है? So I hope this is clear to you. सबको clear हो गया होगा ये किस तरीके से क्या आंसर आया हम लोगों का. ठीक है? So ये हो गया हम लोग का correct answer. चलो. Now move to the next question. That is a mixture of N2 and argon gases in a cylinder contain 7 gram of N2 and 8 gram of argon. If the total pressure of the mixture of the gas in the cylinder is 27 bar, the partial pressure of N2. So this question is also from the Dalton's law of partial pressure. We know the formula that is P, that is Pi, that is the partial pressure is equal to mole fraction. Mole fraction of that component multiplied by the total fraction, total pressure. So this is the formula that we are used for calculating the partial pressure. That is partial pressure is equal to the mole fraction into total pressure. Okay. So a mixture of N2 and argon gases in the cylinder containing 7 gram of O2. These all values are given already. So you need to calculate that partial pressure. Okay. Chalo. So if you want to calculate the partial pressure of N2, for example, partial pressure of N2, then you need the mole fraction of N2 only. So this is the mole fraction of N2 multiplied by total pressure. Multiplied by total pressure. So this formula basically we are going to use. Okay? Chalo. So can you calculate mole fraction of N2? Because here we have N2 and argon. So we know that mole fraction of N2 is equal to number of mole of N2 divided by number of mole of N2 plus number of mole of argon multiply by total pressure. Okay? That is number of mole of N2 plus number of mole of N2 plus number of mole of argon. Now, how will you calculate the number of mole of N2? For example, N2, so number of mole of N2 we can calculate, mass is given 7 gram and molecular mass is 14. So this will comes out to be 1/2. Okay? ये कितना आएगा 1/2. Similar number of mole of argon. तो argon कितना आएगा भाई? That is 8 gram. And what is the molecular mass of argon? That is 40. So this comes out to be 1.5. 1/5. ठीक है? इनकी values को आप put कर दो. तो 1/2 we can write as 1/2. This is 7/28. Sorry, not 14. 28. This is 1/4. Sorry. ठीक है? यहाँ पे correction कर लेना 1/4. 28 होगा ना N2 का. N2 नाइट्रोजन है, डाई नाइट्रोजन है. So 28 is the molecular mass. So ये value कम आ जाएगा 0.25 and 1/5 we can write as 0.2. So just put the value here. So we have N2. So N2 के value हो गया 0.25. नीचे हो गया 0.25 plus number of mole of this, that is 0.2. ठीक है? तो 0.45 हो गया ये, 0.25 प्लस 0.20 दैट इज 0.45 इनटू टोटल प्रेशर। तो टोटल प्रेशर कितना गिवन है, दैट इज 27 बार। सो बस इसको सॉल्व करना है। सो दिस डेसिमल कैंसिल आउट, 5 9 the 45 and 3 9 3 the 27, तो 5 3 the 15, so कितना आ गया 15 बार। so 15 bar is the correct answer, right? So the correct answer is 15 bar। ठीक है, so I hope this is clear। समझ आया क्या सबको? एक बार कंफर्म कर दो फटाफट, सभी कंफर्म कर दो एक बार, समझ आ गया सबको? गॉट द आंसर? ठीक है, चलो। सो दिस इज हाउ विल यू एबल टू सॉल्व दिस सच क्वेश्चंस। ठीक है, चलो। ये भी नीट 2019 में क्वेश्चन आया हुआ है। देखो इसको क्या बोल रहा है ये, कह रहा है कि अ गैस, ठीक है, अ गैस एट 350 केल्विन, सो अ गैस एट 350 केल्विन and 15 bar has a molar volume of 20% smaller than that of an ideal gas under the same condition. The correct option about the gas and its compressibility factor is। तो सबसे पहले तो मैं तुम्हें बताऊं what is compressibility factor। So we can write compressibility factor, that is Z। ठीक है, compressibility factor Z is equal to V real divided by V ideal। अब ये क्या है भाई, V real means that is the real volume divided by ideal volume। Just remember this value। ठीक है, एक सेकंड दो, जस्ट चार्जिंग में लगा ले इसे, जस्ट वेट फॉर अ मिनट। ठीक है, चलो। सो compressibility factor Z is equal to real volume upon ideal volume। This is the formula for the compressibility factor we have। ठीक है, V real upon V ideal। Now here it is given in the question that is has a molar volume 20% smaller than that of the ideal gas under the real condition, right? यानी यहाँ पे साफ साफ दिया हुआ है that is V real कम है as compared to V ideal। ठीक है, यानी वी आइडियल से वी रियल कम है, 20% कम है, यानी है द मोलर वॉल्यूम। वी रियल को हम वीएम भी बोल सकते हैं, वीएम मोलर वॉल्यूम। ठीक है, दैट इज द मोलर वॉल्यूम एंड दिस इज द आइडियल वॉल्यूम, दैट इज वी आई, राइट? वी कैन राइट एज वेल। सो इन द क्वेश्चन इट इज गिवन दैट रियल वॉल्यूम इज लेस देन द आइडियल वॉल्यूम। सो बताओ, अगर ऊपर वाला क्वांटिटी कम हो गया नीचे वाली से, ठीक है, ऊपर वाला वैल्यू कम है नीचे वाली से, तो जेड क्या आएगा? जल्दी बताओ। if the molar volume is less as compared to the ideal volume, means अगर ऊपर 1 है तो नीचे 2 है, ऊपर 2 है तो नीचे 4 है, तो इसका रेशियो क्या आएगा हमेशा? रेशियो एक से हमेशा छोटा ही आएगा, ऑब्वियस सी बात है, एक से तो हमेशा छोटा ही आएगा। इट मींस जेड इज लेस देन 1। ठीक है, it means Z is less than 1 because in this question this statement is given that is the molar volume is lesser compared to the ideal volume, it means Z is less than 1। So in the gaseous molecule attractive forces are dominating whenever Z is less than 1, always remember beta that is attractive forces, attractive forces dominate, dominate। ठीक है, तो जब भी हमारा जेड लेस देन 1 होता है तो कौन सा फोर्स डोमिनेट करेगा? एट्रैक्टिव फोर्सेस ऑलवेज डोमिनेट। तो ये हम लोग को अच्छे से याद रखना है। सो विच ऑप्शन इज करेक्ट बेटा? दैट इज दिस वन, जैसे जेड इज लेस देन 1। whenever the z is greater than 1 then repulsive forces dominated। ठीक है, तो ये याद रखना है, when the z is greater than 1 repulsive force is dominated, when the z is less than 1 attractive forces is dominated। or in this question why only z is less than 1, because in the question itself it's given that is the real volume is less than the ideal volume, that's why। ठीक है, so I hope this is clear to everyone। सबको clear हो गया? or anyone having any kind of doubt in this question you can just ask better। anyone? No? चलो, now the next is the correction factor A to the ideal gas equation correspond to. ठीक है, so the correction factor A to the ideal gas equation corresponds to. A किस पे डिपेंड करता है? Density of the gas. In this we are asking about the van der Waals constant A and B, right? So always remember A and B किस पे डिपेंड करता है? ये A की बात हो रही है यहाँ पे. So density of the gas molecule, volume of the gas molecule, forces of field present between the gas molecule या forces of attraction. So always remember बेटा, this A show the attractive forces, right? यानी ये attractive forces पे डिपेंड करता है, ये attractive forces को बताता है. ठीक, यानी अगर A का वैल्यू ज्यादा है इसका मतलब है वहां पे attractive forces ज्यादा है. और जो ये B है ना, ये बताता है हम लोगों को वॉल्यूम ऑफ द गैस मॉलिक्यूल, वॉल्यूम ऑफ द गैस मॉलिक्यूल. वॉल्यूम ऑफ द गैस मॉलिक्यूल. सो ए और बी यहाँ पे क्या है, हमारे दो कांस्टेंट है. ए अट्रैक्टिव और बी किसको बताता है, वॉल्यूम ऑफ द गैस मॉलिक्यूल. बस इन दिस क्वेश्चन दे आर आस्किंग अबाउट ए ओनली, सो द ऑप्शन इज डी, दैट इज द फोर्स ऑफ अट्रैक्शन बिटवीन द गैस मॉलिक्यूल. चलो, एक और क्वेश्चन आया है. ये क्वेश्चन ऑलरेडी मैंने आप लोगों को बता दिया किस तरीके से सॉल्व करना है, तो फटाफट सभी लोग आंसर्स करेंगे इसका, बिकॉज ऑलरेडी मैंने बताया था क्रिटिकल टेम्परेचर का और लिक्विफिकेशन का क्या रिलेशन है. नाउ यहाँ पे वेन डेर वाल्स कांस्टेंट है, तो ध्यान से समझो. ए क्या बताता है, ए बताता है अट्रैक्टिव फोर्सेस को. यानी अगर ज्यादा अट्रैक्टिव होगा तो ऑब्वियस सी बात है उसका लिक्विफिकेशन इजी होगा ना. हायर द वैल्यू ऑफ ए, लिक्विफिकेशन इजी थी. हाँ, बिकॉज अट्रैक्टिव है. तो लिक्विफिकेशन का मतलब ये क्या है, गैसियस में पार्टिकल दूर दूर है, उनको पास लाना है, तभी तो लिक्विड में बदलेंगे. सो अगर ए की वैल्यू ज्यादा होती है, मतलब अट्रैक्टिव फोर्सेस ज्यादा होता है, तो लिक्विफिकेशन इजी होगा. नाउ ऑन द बेसिस ऑफ दिस डेटा, जस्ट गिव मी द करेक्ट आंसर. The van der Waals constant for ammonia, H2O2 and CO2 respectively, which one of the following gas is most easily liquefied? अब तुम्हारे अंदर क्वेश्चन आएगा सर ये A कांस्टेंट गिवन है या B कांस्टेंट गिवन है. सो फॉर द लिक्विफिकेशन वी रिक्वायर ओनली कांस्टेंट है, तो ये कांस्टेंट A की वैल्यू गिवन है. ठीक है, अब मुझे फटाफट जल्दी से बताओ which of the gas liquefied easily. I'll give you 15 seconds for this. Tell me the correct answer in the chat box. फटाफट. I'm waiting for a reply, guys. फटाफट 15 seconds. Within 15 seconds, you have to reply all. All have to reply. चलो, एक रिप्लाई आया मेरे पास. GNVG H2. Okay. Anyone else? H2 having value 0.244 beta, minimum value. What I'm saying in the previous question itself, ध्यान से देखो उसको. क्या बोला था? A denote the attractive forces. और attractive forces means what? Attractive forces means what? That is liquefaction is easy. भाई attractive forces से liquefaction easy होगा ना? कैसे? गैसेस है, गैसेस का लिक्विफाई करना है, मतलब उसको पास पास लाना है, राइट. सो यू वांट द पार्टिकल टू कम क्लोजर. सो अगर पार्टिकल को दूर से नजदीक लाना है, सो यू वांट मोर अट्रैक्शन, राइट, एंड ए सिग्निफाई द अट्रैक्शन. सो हायर द अट्रैक्शन, मोस्ट इजीली लिक्विफिकेशन विल बी, उसका अच्छे से लिक्विफिकेशन हो जाएगा, जल्दी हो जाएगा. सो आउट ऑफ दिस फोर ऑप्शन किसमें अच्छे से लिक्विफिकेशन होगा, दिस इज द क्वेश्चन. ठीक है, ऑन द बेसिस ऑफ द वैल्यू ऑफ ए, दिस इज द वैल्यू ऑफ ए, राइट. ये सभी ए की वैल्यू गिवन है, वेन डेर वाल्स कांस्टेंट ए व्हिच डिटरमाइन द अट्रैक्टिव फोर्सेस. अब बताओ फटाफट. टेल मी फास्ट द करेक्ट आंसर फॉर दिस क्वेश्चन. NH3. गुड. NH3 इज द करेक्ट वन, राइट. सिर्फ एक बच्चे, एक जेएनवी ने रिप्लाई किया ओनली. ठीक है, बाकी सब बच्चों ने रिप्लाई नहीं किया. So NH3 is the correct. Why beta? Because the value for the NH3 van der Waals constant for NH3 having higher value, ठीक है, 4.17. So for the value 4.17, the value of A is high. So more the value of A, easy win the liquefaction, ठीक है, इसीलिए उसका liquefaction easy हो गया. So the correct answer is NH3. Very good. चलो, now we are going to solve some numerical based, right? That is the integer type questions. So try to solve such questions as well. फटाफट देखते हैं कैसे क्वेश्चन को आप कैसे सॉल्व करोगे, क्या तरीका है तुम्हारा सॉल्व करने का. So the first question is, that is, a certain quantity of the real gas occupy a volume of 0.15 decimeter cube at 100 atm and 500 Kelvin when its compressibility factor is 1.07. Now its volume at 300 atm and 300 Kelvin when its compressibility factor is 1.48. So कह रहा है when the compressibility factor is 1.07, their volume is 0.15 decimeter cube and 100 atm, right? Their volume and the pressure is given. बोल रहा है its volume is 300 and 300 Kelvin when the compressibility factor is 1.48. सबको बताना है कि क्या इसका करेक्ट एक्सप्लेनेशन हो, ठीक है. So let's see the answer for this question. So we all know that what is compressibility factor, अभी भी बताया था. So we can write compressibility factor, that is Z, is equal to PV upon NRT. PV upon NRT. Now from here you can calculate N actually. So this N comes out to be PV upon ZRT. PV upon Z R and T. ठीक है. अब देखो दो वैल्यूज ऑलरेडी गिवन है. Z1 is what? Z1 is given 1.07. What is Z2? So Z2 be given है, that is 1.4. 1.4. P1 is also given. P1 is given 100 atm. P2 300 atm. ठीक है, 300 atm. V1 is given, yes, 0.15 liter. T2 is given 300 Kelvin. T1 is given क्या? T1 भी given है भाई 500 Kelvin. You need to calculate V2 only. ठीक है, you need to calculate V2. They are asking its volume at 300 atm and 300 Kelvin is in decimeter cube. So you need to calculate the volume also. Let's see how will you find this. So basically we can calculate like, because the number of moles, a certain quantity of the real gas occupy a volume of this when its compressibility factor is this, right? And volume 3 when the compressibility factor is this. Okay? So certain quantity is already given. So according to the question, we can say that this P1 V1, that is V1 V1 Z1 RT1 is equal to P2 V2 Z2 R और T2. ठीक है. So P1 V1 upon Z1 R T1 is equal to P2 V2 upon Z2 into R T2. Right. Now from this R get cancelled. This R get cancelled. So now we know all the values. Like we know P1, we know Z1, we know V1, we know T1, P2, T2. So on putting all this value, we can easily calculate the value of V. ठीक है. So easily हम लोग V2 की वैल्यू को कैलकुलेट कर लेंगे. So V2 वैल्यू को कैलकुलेट करेंगे तो कितना आ रहा है 392. एक बार तुम लोग कैलकुलेट करके बताना. I'll give you 10 seconds for this. फटाफट ठीक है, सो आई होप ये निकल गया होगा। फटाफट देखो, V2 कम्स आउट टू बी 392। ठीक है, सो ये है करेक्ट आंसर। सबका यही आ रहा है क्या कैलकुलेट करने पे? 392 10⁻⁻4, बिकॉज इस पे पूछा है ना, तो हम लोग यहाँ निकालेंगे। दैट इज 392 इंटू 10⁻⁻4 डेसीमीटर क्यूब। सो द आंसर इज 392। ठीक है, 392। डन। डन, चलो मूव टू द नेक्स्ट क्वेश्चन। At 600 Kelvin, the root mean square speed of a gas X having molecular mass 40 is equal to the most probable speed of a gas Y at 90 Kelvin. Right. Now the molar mass of the gas Y is. So you have to calculate the molar mass of the gas Y. Right. So at the 600 Kelvin, the root mean square speed of gas X is given, having molar mass is this. And this is equal to the most probable. So in this question, you need to establish the relationship between the root mean square value and the most probable value. So we all know the formula, right? We all know the formula, that is VRMS. Okay, that is VRMS. So VRMS is equal to under root 3KT divided by M. Divided by M. So this is equal to VRMS is equal to under root 3KT upon M. Similar, VMP, that is most probable speed, is equal to under root 2 kT upon M. So in this question they are saying the root mean square speed of the gas X having molecular 40 is equal to most probable speed of the gas Y at 90 Kelvin. So these two values are given. ठीक है, तो फटाफट इसको इक्वेट कर देते हैं। इक्वेशन 1 and this is equation 2. ठीक है, equation 1 and equation 2 we have. So let's see the equation 1 and equation 2. So क्या आएगा यहाँ पे, जल्दी बोलो। That is 3KTX, right, divided by mx is equal to under root 2KTY divided by m1। ठीक है, x और y नाम दे दिया। नाउ ये रूट पूरे पे है, ध्यान रखना, पूरे पे ही रूट है। नाउ स्क्वायरिंग बोथ साइड टू एलिमिनेट द स्क्वायर रूट। सो दोनों को स्क्वायर रूट कर दिया तो क्या बचा? दैट इज 3KTX डिवाइडेड बाई mx। सो 3KTX डिवाइडेड बाई mx, और ये हो गया 2KTY, 2KTY डिवाइडेड बाई my। ठीक है, so 3KTY divided by mx is equal to 2KTY divided by my। So in this question they're asking us to calculate the value of my, right? We know all the values except this, so we just need to calculate this value. So the value of this k and this k being cancelled, so 2 into Ty. So what is the temperature of y beta? 90 Kelvin. So 2 into 90 we have. ठीक है, so इसमें तो कोई इशू नहीं है। 2 into 90। Now what is the molecular mass of X? That is 40 is equal to here we have 3, I guess. ठीक है, 3। Here we have 2 into Ty. So Ty that is एक सेकंड रुको, ये Tx था ना, ये Tx था, यहाँ पे गड़बड़ हो गया। तो 3 into Tx का टेम्परेचर कितना है, जल्दी जल्दी बताओ प्रॉफिट। 600 Kelvin। 600 Kelvin। This is 2 into 90 Kelvin। ठीक है, एंड my you need to calculate। तो बहुत सिंपल सा कैलकुलेशन हो गया, आप तो कर ही लोगे। सो my is equal to 2 into 90 divided by 3 into 600, right? my निकाल रहा हूँ, into 40। सो देखो 0 0 गेट कैंसिल, अगेन 0 0 गेट कैंसिल, ये 3 से 9 3 टाइम्स कट गया, तो 2 3 जा 6 6 4 जा 24। ठीक है, तो कितना आ रहा है? 24 आ गया। नाउ अब क्या करना है हम लोगों को? my। Again, this will be 2 into 3, 6, 6 for the 24, 24 divided by 6. तो ये आ गया लगभग 4. ठीक है, तो ये आ गया लगभग हम लोग का 4. Now, in gram per mole, we have to calculate ना. So 4 gram per mole. So answer is 4 gram per. So ये हो गया correct answer. So I hope this is clear to you. सबको समझ आया क्या? कोई ऐसा जिसको समझ नहीं आया, यू कैन आस्क अगेन. और क्लियर है सबको? फटाफट एक बार कंफर्म कर दो. क्लियर है सबको? चलो. Now, do this question. At a constant temperature, a gas is at a pressure of 940.3 mm of Hg. The pressure at which the volume decreased by 40% is. So at the constant temperature, the condition is given at the constant temperature. So in this, we are going to use the Boyle's law, right? Because in Boyle's law, temperature is constant. So for the Boyle's law, we know that PV is equal to nRT. nR is already constant. This T is also constant. So this whole term becomes constant. So we can say that PV is equal to constant. So we can write as P1 is equal to P2 V2. Okay? According to the Boyle's law. Now, at a constant temperature, a gas is at a pressure. The pressure given है 940.3. ठीक है? Volume का कुछ है भाई? नहीं. That is V1. The pressure at which the volume decreased by 40%. अब कौन सा प्रेशर है जिसमें वॉल्यूम 40% डिक्रीज हो जाए? मतलब अगर ये वॉल्यूम V1 है तो इसका 40% डिक्रीज वॉल्यूम लिखना है और प्रेशर तो निकालना ही है. तो इसका कितना 40% डिक्रीज हो जाए, मतलब कितना बचेगा? 0.6 ऑफ V. ऑब्वियसली बात है 40% डिक्रीज हो जाने का मतलब 60% ही तो लेफ्ट हुआ. 0.6 इंटू V. नाउ वी कैन इजिली कैलकुलेट दिस P2. सो P2 कितना आएगा? ये आ जाएगा आपका 940.3 हाँ इंटू V1 divided by 0.6 V1. This V1 get cancelled 943.06. So बस इसको सॉल्व करना है. So solving what you'll get बेटा 940.3 mm of Hg divided by 0.16. ठीक है, so बस इसको सॉल्व कर लो. So you get to know that value comes out to be 1567 mm of Hg. So this is the correct value. That is 1567 mm of Hg. So in the nearest integer we can write it 1567. ठीक है, so 1567 mm of Hg is the correct answer for this question. So I hope this is clear. ठीक है सबको? Because in this question it's a very simple one. The first clue given here is that it's a constant temperature. So from this data, we came to know that this question is from the Boyle's law, because in Boyle's law only the temperature remains constant. So at the constant temperature, a gas is at a pressure of this mmHg. The pressure at which the volume decreased by 40%. So you need to calculate the pressure at which its volume decreased by 40%. ठीक है, तो कितना आया 1567 of mm of H2. So ये हो गया हम लोगों का करेक्ट नियरेस्ट इंटीजर. ठीक है, चलो. The next question is the total pressure of the mixture. ठीक है, the total pressure of the mixture of non-reacting gases X 0.6 gram and Y 0.5 gram in a vessel is 740 mm of Hg. Total pressure is given. You need to calculate the partial pressure. So this is again the question from the Dalton's law. So this is a very simple question. We already solved such type of questions, right? कैसे करते हैं? If you want to calculate the partial pressure, just multiply by the mole fraction. So किसका निकालना है? Partial pressure of the gas X. So mole fraction of the gas X multiply by the total pressure. So we know the total pressure, then we can easily calculate. So this equation we need to use. Now, how will you calculate the mole fraction of the gas X? ठीक है, how will you calculate? So mole fraction of the gas X is equal to number of mole of X divided by number of mole of X plus number of mole of Y into total pressure. So can you calculate the number of mole of X? Because mass is given 0.6 and the molar mass is also given, that is X20. And for Y, the value is given 0.45 divided by 45. So we can easily calculate. So the mole comes out to be 0.03 and this value comes out to be 0.01. Okay, 0.03 divided by 0.03, ठीक है। तो ये हो गया। now just put the value, so on putting the value we got 0.03, 0.01 plus 0.03, ठीक है, and multiply by 740, so we can get to know that is 555 mm of Hg, ठीक है। video is buffering, okay, एनीवन और भी किसी को प्रॉब्लम आ रही है क्या वीडियो बफरिंग की, या सब कुछ क्लियर है बाकियों को? ठीक है। सो दिस इज ऑल अबाउट दैट इज द 555 mm ऑफ Hg, सो दिस इज द करेक्ट आंसर, ठीक है। दैट इज द टोटल प्रेशर ऑफ द मिक्सचर ऑफ द नॉन रिएक्टिंग गैसेस X एंड Y, सो यू नीड टू कैलकुलेट द पार्शियल प्रेशर ऑफ दिस, ठीक है। तो पार्शियल प्रेशर ऑफ दिस गैस आपने कैसे निकाला? बाय यूजिंग दिस फॉर्मूला, ठीक है। सो बाय यूजिंग दिस फॉर्मूला वी कैलकुलेट द पार्शियल प्रेशर ऑफ दिस। आई होप दिस इज क्लियर सबको। चलो, ट्राई टू सॉल्व दिस क्वेश्चन एज वेल, ये क्वेश्चन भी बिल्कुल सेम है, तो ट्राई टू सॉल्व दिस क्वेश्चन वेल, ठीक है। दैट इज द x gram of molecular oxygen is mixed with the 200 gram of neon. The total pressure of the non-reactive mixture O2 and the neon in the cylinder is 25 bar. You have to calculate the partial pressure of neon is 20 bar at the same temperature and volume. The value of x. So फटाफट कैलकुलेट करने की कोशिश करो इसको एक बार। समझ रहे हो क्या बोला है इसमें? हम्म, x gram of molecular mass. So you have to calculate the value of x, mass of the solute, right? So x gram of this you need to calculate. कैसे निकलेगा? सेम फॉर्मूला अप्लाई करना है, जस्ट लाइक द प्रीवियस वन। दैट इज द पार्शियल प्रेशर ऑफ नियॉन इन दिस केस यू नीड टू कैलकुलेट। हाँ, so partial pressure of neon is equal to a mole fraction of neon multiply by the total pressure, ठीक है। Now partial pressure of neon is given, that is 20, mole fraction of neon you need to calculate, and PT is also given, that is 25। तो चलो इस पे ध्यान देते हैं कैसे निकालें। तो मोल फ्रैक्शन ऑफ नियॉन इज इक्वल टू नंबर ऑफ मोल ऑफ नियॉन प्लस नंबर ऑफ मोल ऑफ नियॉन प्लस नंबर ऑफ मोल ऑफ O2। Now how will you calculate this? So mass of the neon is given, that is 200 gram divided by the molecular mass. Again this is 200 divided by 20 plus NO2, that is x upon 30, x upon 32. So this x you need to calculate. So just put the value here. So अगर यहाँ वैल्यूज को पुट करते हो तो कितना आता है जल्दी बताओ। अगर इस वैल्यू को पुट कर दो तो पूरा सॉल्व करके कितना आ सकता है फटाफट। दैट्स 20 upon 25 and this is 200 upon 20, 200 upon 20 plus yeah, that is the value is, ये क्या है कितना है भाई O2, कितना ग्राम दे रखा था O2 हम लोगों को, या x, ये तो निकालना है, दैट इज x अपॉन 32, ठीक है। सो जस्ट इस x को कैलकुलेट करना है बाय सॉल्विंग। तो ये काम तो कर ही लोगे, इतना तो सॉल्व आसानी से हो जाएगा ना, ठीक है। सॉल्विंग यू विल गेट 80 ग्राम, ठीक है। सॉल्व करने पे कितना आएगा? 80 ग्राम आएगा। तो दिस इज द करेक्ट वन, ठीक है, दैट इज द 80 ग्राम। आई होप दिस इज क्लियर। समझ आया कि 80 ग्राम कैसे आया? ठीक है। सो दिस इज ऑल बेटा। सो ये सब हम लोगों ने कुछ इंपॉर्टेंट क्वेश्चन थे जो हम लोगों ने डिस्कस किए, तुम्हें भी ऐसे ही करने हैं। कुछ क्वेश्चन है फॉर होमवर्क के लिए तुम प्रैक्टिस कर सकते हो, जैसे ये क्वेश्चन है, दिस कैन यू कैन सॉल्व एज अ होमवर्क क्वेश्चन, ठीक है। ये नोट कर लो, स्क्रीनशॉट ले लो इसका। सो इन सब क्वेश्चन को सॉल्व कर सकते हो। तो वी सॉल्व ऑलमोस्ट नो 20 to 30 क्वेश्चन, और बहुत अच्छे अच्छे क्वेश्चन, हर टाइप के क्वेश्चन को डिस्कस किया, इंक्लूडिंग नीट एज वेल एज द जेईई मेंस, ठीक है। नो ये क्वेश्चन भी इंपॉर्टेंट है, सो ट्राई टू सॉल्व ऑल दिस क्वेश्चन, ठीक है। सो आई होप इट्स क्लियर टू एवरीवन। किसी को कोई भी डाउट नहीं है ना? कोई डाउट नहीं है? एनीवन कोई डाउट हो तो पूछ लो फटाफट। नो? चलो, सो वी एंड दिस मीटिंग, ठीक है। इस मीटिंग को एंड करते हैं यहीं पे, और हम लोगों ने सारे क्वेश्चंस किए, तुम लोग इसके प्रैक्टिस करो। इन टुमारो क्लास एज वेल वी आर गोइंग टू सॉल्व सम मैथड रिलेटेड टू दिस चैप्टर एज वेल, ठीक है। सो नो वरी, कल भी हम लोग कुछ क्वेश्चंस को सॉल्व करेंगे। टिल टेक केयर, और इसको सॉल्व करो अच्छे से, ठीक है।